the next focus that we will be looking into is how to graph the inverse function. Now, when we are going to graph the inverse function, we will review again how to graph the function. Okay? So, now, you will notice our focus in here is the inverse function, and we are going to plot them. Definitely, when we are going to plot or graph, we have to look into the domain of the given function. Okay? Now, after having now the domain, that's the time we can assume. We can call now, or we can give now possible value of x. Values of x. And then, if we have already the values of x, then we can compute now for the result of f of x, or we can evaluate now the function if we have already the values of x. Okay, I hope you're following. Okay? Now, notice that with 1 and 2, they are not absolute. You can make use of your own guide. Okay? But my guide, or our guide that I will be sharing to you, this one. So again, for us to graph the function, the number one that we are going to look into is we will find the domain or state the domain. Okay? As what we have said last time, when a function is stated just this way, without any limitation, we have said that the domain are all real numbers. Okay? There is no such limitation if the function is stated like this one. I hope you're following. Now, so that if there is no limitation, we can just say the functions or the domain of the function are all real numbers. After that one, then we can assume now the values of x. So, our focus in here is the graph of the linear function. So, this is the linear function. Now, how are we going to look into the graph of this one? Again, what are the things that we have to satisfy? The domain. Okay? So, we will state, what are the domain? All real numbers. Okay? All real numbers. Yan. So, after having now the domain, meaning to say, the next thing that we're going to look into is possible values of x. Now, for the sake of plotting the graph, we will at least make use of 5 values of x. We have the negative numbers, we have the positive numbers, including the 0. So that is how we are going to do. Okay, so how is this? Meaning to say, I will be putting my values of x, or I will be creating my own table. Okay? So my x, or your x in your function, meaning to say we will assume possible values of the function, include negative. So shall we say we have in here 5, we have in here 3, we have 0, negative 3, and negative 5. Okay? Would this be possible? Yes. Why? Because the domain are all real numbers. Okay? And then after that one, it says in there, we will compute now for what? For the value of f of x. Okay? We will compute now for the values of f of x. So again, to graph a function, the very first thing that we will be doing is we will analyze. After analyzing them, then we can now find the domain. Okay? The domain of the function. After having now the domain, saying the domain are all real numbers, that's the time we can assume now the values of x, or the possible values of x. And so after assuming the possible values of x, you can now state, we have 5, 3, 0, negative 3, and negative 5. So, there are 3 kinds of number. What are the kinds of number? Positive numbers, neutral number, and then negative numbers. When I say neutral number, that is the 0. After having now the values of x, that's the time you can compute now. Okay? You can compute now the values of f of x. And so, if you're going to have now the computation, after the computation, plotting. The very last part is plot. Okay? So, let's try to do them. Okay? Let's try to have this one. We have in here, if the x is said to be 5, what would be now the f of 5? So we have now f of 5 is equal to 2 multiplied by 5 minus 3. And so it will give you now, that is the same as multiply minus 3, 7. What about if your x is 3? Okay? X is 3. Now, what would be now the value of what? F of 3. Okay? What would be the value? Let's try to have it again. That is the same as saying F of 3 is equal to 2 multiplied by 3 minus 3. So, that is the same as 6 minus 3, 3 and 3. Next, you notice that we have another value that is x is 0. Now again, what is the value of f of 0? It will give you now, that is the same as, we say f of 0 is equal to 2 multiplied by 0. And that is minus 3. That is 0 multiplied by 2. 0 minus 3, it will give you negative 3. Are you following? Next, we have in here we have the negative 3. Now having the negative 3, your x is negative 3. Now what would be the result of f of negative 3? Now, having said this one, you can now substitute. Okay, substitute. So that is the same as f of negative 3 is equal to 2 multiplied by negative 3 minus 3. 2 multiplied by negative 3, negative 6 minus 3, negative 9. Addition of like signs. Okay? Now, x is equal to negative 5. Now again, what is the value of prime? Right, to have them. So that is the same as, put it here. Let's try to put it here. F of negative 5 is equal to 2 multiplied by negative 5 minus 3. 2 multiplied by negative 5, negative 10 minus 3. Negative 13. If our x is 5, the result is 7. If our x is 3, the result is 3. If our x is 0, the result is negative 3. If our x is negative 3, the result is negative 9. And if that is negative 5, the result is negative 13. These are now the things that you are going to what? You are going to plot. Okay, we will plot now this one. Yes. I hope you are following. Okay? I hope you are following. So, the next thing that we are going to have now is we are going to plot. Notice that after having now the computations that we have, there's a time now we're going to put them into table, or if not into table, so that it is very easy to plot them. Now you try to itemize, or you try to state them one by one as points. So meaning to say, our points, okay, the points that we are going to plot would be what? We have 5 and 7. It will be followed by 3 and 3. It will be followed by 0 and negative 3. It will be followed by negative 3 and Negative 9. And the last one would be negative 5 and negative 13. When we plot them, we try to do them one by one. We have in here the Cartesian plane. It is calibrated 1, 2, 3, an interval of 1 unit until 10 because our highest y is 7. Okay? Our lowest y is 13. And so as you can see, 13. Okay? In my y-axis, the maximum y is 10, just to include 7, and the minimum y is 13 to include negative 13. Now what about the values of x? Okay, our values of x is stated already, that is the same as from positive 5 going to negative 5. Okay? You can plug them now. Okay? Notice that point 1 is 5 and 7. So it is in the what? First quadrant. Okay, so our x is 5. Okay, we have in here. Then our y is 7. So it is somewhat located in here. Okay, is it aligned? Okay. Now next, 3 and 3. Our x is 3. Our y is 3. So where is our x? We have in here. Our y is 3. So you try to align the points, the location of the points. So we have in here. Is it aligned? Okay, that is point 3 and 3. The next one, 0 and negative 3. The x is 0, so we have in here. And the y is negative 3. So where is that? It is located in here. 0x, negative 3 ang y. So your point is located in here. Okay? So, next, negative 3, x is negative 3, negative y, 9. So, where is the negative 3? We have in here, the negative 3, and of course, the negative 9 is located in here. Okay? So, this is our point. Next, negative 5 and negative 13. Where is that? Negative 5. The x is negative 5, so it is in here. What about 13? It is located in here. So, after having now the points, that's the time we're going to connect the points. So, let's connect. So, we have this one. So, this is the line of our function. This is the line of our function. Now, after plotting now the points, and then connecting the points with your line, there's a time now that you're going to label them. What do I mean label them? Label the points. So what is the name of this point? That is named as 5 and 7. Okay? How about here? 3 and 3. How about this one? 0 and negative 3. How about this one? That is negative 3 and negative 9. How about here? Negative 5 and negative 13. So those are the label of the points. Now after labeling the points, label the line or name the line. So what is the name of the line? The name of the line is always the function. What is the function that we have? F of x is equal to 2x minus 3. Okay? So that is the label of the line and then the points that we have in here. The next thing that we're going to do is get the inverse of this one. Okay? Because that is our focus. So graph and the graph and the inverse function. So notice that when we get the inverse of this one, the first thing that we're going to do is change f of x. Change of f of x to y. So what is our function? We have in here or this one. f of x is equal to 2x minus y. What are we going to do? We say y is equal to 2x minus 3. What is the next thing that you will be doing? Interchange. Interchange x and y. Okay, interchange. So meaning to say, we will be having now x is equal to 2y minus 3. And after interchanging them, that's the time we are going to compute for the new y. That's the time we're going to compute for the new y. So meaning, that is the same as x plus 3 is equal to 2y. Now isolate now the y. So what are we going to do? Divided by 2. So what would be now the new y that we have in here? That is the same as y now is equal to x plus 3 divided by 2. It says in there in step number 4, because we have the new y, we change now the new y to what? F of negative 1 to indicate that what you computed is the inverse. So how is that? We have now f raised to negative 1 of x is equal to x plus 3 over 2. So we have now a new function which is called to be now the inverse. Inverse. Okay? Inverse. Inverse function. Again, after having the inverse function, we will plot them again. Would it be the same with the original graph? Now let's try to see that one if that is the same. We make use of just the same values of x. Okay? So we will try to make use of the same values of x. So we will still make use of 5, 3, 0, negative 3, negative 5. Now, what will be the inverse? The result. Okay? What would be the inverse? Notice that, again, our inverse function is f of x is equal to x plus 3 over 2. The same, the domain are all real numbers, or we just interchange the values that we used a while back. Okay? Now, if we opt to change the values of x, then we can still make use of this one. Only that, we use the inverse function. So what would be the value of our inverse if our x is 5? So that is the same as, we have now f of 5 is equal to 5 plus 3 divided by 2. 5 plus 3 divided by 2, 4. Next, what if our x is positive 3? What would be the result of what would be the result of the inverse function of 3? F of 3 is equal to 3 plus 3 divided by 2. Result? 6 divided by 2? 3. What about if the x is negative 0? What would be the f, or what would be the inverse function of 0? Okay? What would be the result? We say f of that is 0 is the same as 0 plus 3 divided by 2. Result? 1.5. Same. What about if our x is negative 3? What would be the result of the inverse function? Okay? Inverse function which is negative 3. Result? That is the same as saying f of negative 3 is the same as negative 3 plus 3 divided by 2. Result? 0. Okay, 0. What about if we have in here f of negative 5? What would be the result? We have f of negative 5 is the same as negative 5 plus 3 divided by 2. Negative 1. Okay, negative 1. So we have now, that is the same as if our x is 5, that is 4. If that is the same as 3, that is 3. If that is 0, 1.5. If that is negative 1, 0. If that is negative 5,
Negative 1.
1. We write in here the inverse, so that the points we have are 5 and 4. Where is 5 and 4? 5 and 4. Dito. Next, where is 3 and 3? We have in here 3 and 3. Dito pa din. The next one is 0 and 1.5. So 0. The x is 0. X is 0. 1.5 ang dito. Okay? 1.5. Another, that is negative 3. That is
0.
0. Where is that? Negative 3. Dito. Now, after that, we have now negative 5, 1. Negative 5, 1. So we have in here. After that one, there's a time we're going to connect. Disconnect. Okay. So that is the graph. Now, we use single Cartesian plane in here so that we can see the effect of inverse and then the original function. Do you follow? So that is the effect. So what is this? We name them, this one, that is f of x, that is x plus 3 over 2.